We don't really think about wire as a component a lot of the time, but we're working on a project right now with some instruments that are going to go way deep underground, kilometer deep or more. We're not talking about a little bit of wire. We're not even talking about a pretty big roll of wire that's going to go on these instruments. We're talking about a single piece of wire that's at least a kilometer long. And we need to know how that affects our system. So we built a simulator to help us find out. So to test it, this is what we came up with. This is a 22 gauge wire simulator based on the resistance of the wire that we're going to buy for this application. And we've got 10 ohm and 27 ohm resistors. These were just little metal film resistors. I got 2-watt resistors off Amazon. They're rated to 1% tolerance. You know, they're Amazon resistors, but I've used these on several things now and I've had no problems. I don't have to pay DigiKey shipping and wait for that to happen. I get them primed generally next day. So they're not bad resistors. And we just put them on the back here and put terminals so we can now plug and simulate different lengths of wire, 200, 500, add another 5, another 5, another 5, another 5. And we built 2 because of course we've got power going down and then a ground return path and we need to simulate both. Why did we have to build this and not just have the wire on a spool that would clearly be a lot bigger than this? Well, when you have a lot of wire on a spool, that's made a coil and I don't want to have to fight the induction that's going to happen with that when we turn the power off. And I don't really have space to leave all that wire laid out. We have to have room for forklifts and things to drive around here. So the simulator lets us bench test things to make sure there are no problems before we lay all the wire out and do the final acceptance test on the device.